Hi, this is Randall Schwartz, host of Floss Weekly. This week, Jonathan Bennett joins me. We're going to be talking about Bedrock, which is a distributed database based on Sqlite. Pretty amazing stuff. You're not going to want to miss this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Floss Weekly is provided by CacheFly at CacheFly.com.
This is Floss Weekly with Randall Schwartz and Jonathan Bennett. Episode 456, recorded October 25th, 2017. Bedrock. This episode of Floss Weekly is brought to you by Rocket Mortgage by Quicken Loans. Home plays a big role in your life. That's why Quicken Loans created Rocket Mortgage. It lets you apply simply and understand the entire mortgage process fully, so you can be confident that you're getting the right mortgage for you. Get started at rocketmortgage.com/floss. It's time for Floss Weekly, the show about free, libre, open source software. I am your host, Randall Schwartz, Merlin at Stonehenge.com, bringing you each week the movers, the shakers, the big projects, the little projects, projects you may be using every day and totally unaware of it, projects you might want to download right after this show and play with. I bet today's is going to be one of those. Joining me once again is my lovely and talented co-host, Jonathan Bennett. Welcome back to the show.
Hey, Randall, always a pleasure.
I should say probably you're like at least my second most favorite, not favorite. Oh, no, I didn't say that. Frequent. I was going for frequent, and I said favorite. Boy, that's a Freudian slip. Okay, right.
I'm a little hurt. I'm only your second favorite, Randall.
Second most frequent. Actually, no, I think you're the most frequent now. So I think if I went back and looked at the list, you're probably right up in there because you're always the one that's always available. You have a flexible schedule and you don't have meetings to go to all the time or conferences to attend or like me and things like that. So I appreciate all your effort, all the times you can be on this show. And where are you speaking to us from? Probably the same old Oklahoma place, right?
Yes. I'm in the corporate headquarters, the home office here in Lawton, Oklahoma, the flyover state.
Cool. I flew over you probably 3 or 4 days ago, and I'll fly over you again next Monday. So there we go.
Don't forget to wave.
So I'm bouncing from coast to coast. So, and the reason I'm bouncing from coast to coast is I have just spent the 2 most wonderful days here in Raleigh, North Carolina, currently in the hotel, sort of one extra day so I can make sure I have time to do Floss Weekly here. But the allthingsopen.org conference was absolutely wonderful. I'll talk more about that at the end of the show, but that's where I've been. That's why I'm in Raleigh. That's why I got no sleep the last couple of days because the conference always drains me pretty bad. But it's great. It is a wonderful conference. Again, I'll tell you more about it at the end. I don't want to tie up the openings with this. But anyway, so I'm in a hotel somewhere in Raleigh, North Carolina. I won't mention the brand name because sometimes they suck. All right, so what do we got today? What we have today is David Barrett is going to be talking to us about Bedrock Db. Now, Bedrock DB is fascinating project. As I look more and more into this, I see what an amazing combination of techniques and technologies. So, distributed databases, all the rage. Everybody likes those, right? And there have been a lot of ways to scale out things like Mongo and Postgres and things like that. But what these guys have managed to do is take, amazingly enough, Sqlite. We had Richard Hipp on the show a couple times, wants to talk about Sqlite itself and wants to talk about his distributed version control system called Fossil. But Sqlite is a fully mature, non-server database. And by that, I mean that it actually embeds as a library into your application. And so what these guys for Bedrock DB, what they did is they said, well, let's make it scale. Because we could have an in-memory application or in-memory database, but we then put it across multiple machines, multiple data centers, and have it figure out when you add new transactions to actually distribute those transactions to everybody else that needs to take care of it. And it starts out looking a little bizarre, but it's like, okay, it even has things like a MySQL adapter, so you can talk to Bedrock using your standard MySQL clients. That's pretty cool too. So very, very cool stuff. Of course, we're going to bring on David in a few minutes to talk about that. What do you know about this so far, Jonathan?
Well, you've covered it very well. When I was looking at it, the first thing that came to mind is that Bedrock, this is not from Minecraft. Which is probably what some people immediately thought of. It's interesting. I know it is a difficult problem to be able to do replication across many places and keep everything in sync. And so, it'll be interesting to hear some of their techniques for doing that. But I am going into the show somewhat fresh, so I'm looking forward to learning about it.
Awesome. I mean, I think there's even some features, I think, like multi-master. So, like, basically you can talk to any one of the nodes and put transactions on there, and somehow they all get rippled out correctly. That sounds like a thorny problem. It sounds like they probably have solved it, and that'll be really cool. So we'll have David Barrett on in just a minute. But before we do that, I do have a very important message, because this episode of Floss Weekly is brought to you by Rocket Mortgage by Quicken Loans. The mortgage experience wasn't keeping up with the times. It was dated, and it needed a client-focused technology revolution. That's why Quicken Loans created Rocket Mortgage. Rocket Mortgage gives you the confidence you need when it comes to buying a home or refinancing your home loan. It's simple, allowing you to fully understand all the details and be confident you're getting the right mortgage for you. It's convenient. Their trusted partners allow you to share your financial information with Rocket Mortgage at the touch of a button. It's also powerful. Whether you're looking to buy your first home or your 10th, Rocket Mortgage is able to perform thousands of calculations in seconds. Based on your income, assets, and credit, Rocket Mortgage can analyze all of the home loan options for which you qualify and find the one that's just right for you. Rocket Mortgage by Quicken Loans. Apply simply, understand fully, mortgage confidently. To get started, go to rocketmortgage.com/floss. That's rocketmortgage.com/FLOSS. It's an equal housing lender, licensed in all 50 states, and MLSconsumeraccess.org number 3030. And we thank Rocket Mortgage by Quicken Loans for their support of Floss Weekly. And let's go ahead and bring on David Barrett. David, welcome to the show.
Hey, thanks for having me.
Cool. And where are you speaking to us from?
I am from Portland, Oregon. We've moved an office up here, and I love it.
Oh, that's my home. I'll be there in 4 more days.
Oh, great. Well, you'll have to stop by when you're here.
Yeah, that'll be cool. All right. I had no idea you were a Portlander. What an awesome thing. And I go halfway across the country to interview you. And I was interviewing you from Beaverton last week. So that would have been funny if I was in Beaverton, you were in Portland. That would have been like, okay, well, I'll just wave at you. Really close. I'll wave in your general direction this way, but it's probably out here somewhere. I have no idea which way.
That's right.
Northwest actually is from here. So let's talk about the 30,000 foot view. So when I'm reaching for Bedrock DB, what problem am I solving?
Well, I think the problem is you want a simple database that can be scale and replicate across data centers. I would say those are the two main things, and that the cross data center one is the most important one. I think the idea of a WAN replicated database is sort of a rare thing, and I think that's where a lot of the sort of off-the-shelf options, especially MySQL, kind of breaks down.
And how did I do for the description? Is it pretty close? Did I get anything horribly wrong?
Yeah, I think that's pretty good. I mean, I would say you're right. The history that went into it is a bit unusual in that when we started off, MySQL didn't have any sort of notion of distributed transactions, which is crazy, but they came kind of late. And furthermore, they're not really optimized to work in a sort of across the internet connection. They're very much designed to work across a very fast sort of like gigabit network, not a very slow sort of like megabit internet connection. And so the reliability and latency and speed of a WAN connection is just a completely different ballgame when you're dealing with distributed transactions. But I think in a modern day, if your application is limited to a single data center, like you're just planning to fail. Like it doesn't matter how good your data center is, it's going to go down. And so I think that if you're not running your application in a distributed manner across, I personally think the magic number is 3 data centers. I think you're just not building a modern application.
So tell us more about the technology here. So I got that right. It's Sqlite as the core. And then what do you have around that to make this all work?
Sure. And so the major thing that always blows people's minds is Sqlite. They're like, what? How could this possibly work? It works on my phone. It works on my browser. How could it work on a server? And even Sqlite guys, they were skeptical at the start. But the database is amazing, like absolutely amazing. The performance is unbelievable because, I mean, if you think about it, Sqlite was built in a modern environment, whereas a lot of the current databases were built in a really antiquated world where there's spinning disks, there's highly constrained RAM, there's a whole bunch of like really tight constraints which just don't exist today, but they've got the baggage sort of built based upon those assumptions. Whereas Sqlite's built for a real simple file system with plenty of RAM, and it describes kind of what a modern server environment is, but everyone sort of forgot about that. And Sqlite is so fast because it doesn't have any sort of networking component. When you query it, you're querying directly into RAM. Like your APIs can get immediately access to RAM. And so there's no process overhead. There's no kernel switching. There's none of this junk that comes along with sort of MySQL and the databases. It's so fast and it's so scalable. I mean, in every way, I just don't know why people wouldn't use SQLite more. It has every feature you could possibly want. It has so many features that you'll never even use. And I think that it's just an incredibly powerful thing. Plus, you mentioned Richard Hipp. The SQLite team is just amazing. Like, these are some of the best engineers in the world. And it's a small enough organization that you can talk to them and get answers and understand what's going on. So I just can't rave enough about SQLite. And so I was a fan of the database before. And when I had my problem where I'm like, hey, I want to build a modern application distributed across different data centers, I'm looking to the options out there, and they're pretty bad. I mean, they're not great now, but at the time, Percona was just starting. MySQL didn't have anything like this. Oracle is just a disaster. And so I wanted something that I could make work. And my background's in peer-to-peer programming, things like this. I'm like, well, SQLite's amazing. And a distributed transaction layer isn't that hard, I guess. I could probably write that. And so I just started with a C++ sort of Paxos-style distributed transaction layer on top of SQLite and kind of went from there. And now, about 10 years later, now we have an incredibly hardened system that processes billions of transactions and very large databases, and it's powering essentially all of the Expensify website and mobile service basically on SQLite. And it blows people's minds, but it is amazing.
So you just mentioned 10 years. I thought this was a fairly recent project. Has this been around for a long time then?
Oh, I started working on it in probably 2008. I think it's more like 9 years. Actually, it's 2007, so 10. Yeah, let's call it 10. And so it's been around for a while. I would say we've gradually worked through order of magnitude after order of magnitude, scaling up Expensify, and it's the core technology that powers everything that we do, and it's, I would say, a big part of the secret sauce of Expensify.
Cool, but now it's open source, and that's fairly recent, right?
Yes. Okay, we've open sourced it pretty recently, but it's been stable and in production for a very long time.
And so what does the architecture actually look like? So you've got an SQLite library that you're using, and you've got some sort of wrapper around it, and then that provides probably client-side socket-facing stuff, right? And then probably there's some peer-to-peer connections going on as well. How does it all play together?
How does it all work together? Sure. And so there's the SQLite at the very bottom. And then on top of that is our clustering layer. So the clustering layer works as follows, and that is when it starts up, each node, and they're all equal, but they have a priority. And so they'll basically go into a searching state, try to just contact as many of their peers as they possibly can. Each one basically knows how far along in the database it's replicated. Essentially, it maintains a journal, which is a sort of a consolidated SQLite, or it's a SHA hash of basically all past queries that have been committed to that database. And so every database commits in the same order, though it does have multi-write capability, which people don't realize that SQLite is a very concurrent database, but we use all that capability. So everyone starts up, sees who they can connect to, figures out who has the most data. They share it all amongst themselves. And then they basically elect a master. And this is where sort of the Paxos consensus algorithm comes from. And master election is very tricky art in a distributed environment where everything can go wrong and everything does go wrong. Once they agree on a master, then basically the master will announce itself. Everyone will approve that. And then everyone will start sort of slaving to that master. And so everyone will basically, every node has a complete copy of the entire database. And thus, every node to the client layer looks equally capable. You don't have to be aware of which one the master is, and the information is generally sort of hidden from you anyway. You send it from the client perspective, where it's PHP or using MySQL client or something like this. You will connect to the any of the nodes. All of the read commands will be executed locally in by default, it uses as many threads as there are cores represented in the system, but you can configure that. And then any writes are escalated to the master. The master will use a variety of techniques to figure out essentially if it needs to replicate that, if it needs to wait for consensus, or if it's just going to commit it or what. It will do the process, or it'll initiate the transaction. If we assume it's a distributed transaction, it will basically wait for a quorum of all of the slaves to respond, and then it will respond the answer back to the initial one that escalated it and send it back to the client. Now, there are a ton of details in there, and I think one of the strengths of Bedrock is that it's not built in an academic environment. It's not sort of a solution in seek of a problem. Everything it does was built in response to real-world problems, and so as a result, it has a tremendous amount of resiliency against all sorts of weird failure conditions, and real problems that have happened.
Well, the fact that you said every node has an entire copy of the database, that means you're not actually ever implementing something like sharding then, right?
Yeah, I don't know. I guess maybe I'm a bit contrarian when it comes to database design. And I think that people freak out about the wrong things. Like if you're talking to a database, like, and I think a lot of these sort of academically developed databases are like, yes, our database is amazing. It can support 50 petabytes of data. I'm like, who the fuck has that problem? Like really? It's like, and if that's what they care about, what are they ignoring? Like, how are they prioritizing this insanely large data set that almost nobody has, and I'm sure none of our customers have? And so, what about the real stuff? Like, I don't know, does it work at all? It's like, get some of the basics down. And so I'd say, like, yeah, the Expensify database, the entire thing. We've got millions of users, and we're the fastest growing in our space, and we're like the second largest in our entire space. And the entire database comes out to around 700 gigabytes. And some people will be like, oh my God, that's so small. That doesn't matter. It's like, well, I don't know. It seems to be big enough to run our entire business. And so, like, what do you know? And so I think that, like, yes, like, it's easy to get 700 gigabytes of RAM. And so just run the entire thing in RAM. And if you're not doing that, why not? It's like, just buy bigger servers. Servers are freaking cheap. And so I think that there's a lot of people who are trying to solve hard problems in software that are really easy to solve in hardware. And I think that people just forget that there's, like, if you can own your entire stack and just solve it at the right place, then it just makes these problems so much harder or so much easier depending on how you choose to do it. And so, yes, I would say that I think for the highest performance, you should buy big enough servers that have enough RAM for your entire database. You should buy, like, good SSD drives, NVMe if possible. And then you should get 6 of those, put 2 of them in each data center, and then you should configure it all with the Bedrock cluster, and then boom, you've got a crazy fast, super reliable service. And if you can't do that, like, why not? Like, the servers are freakishly cheap anymore, and if you aren't using them correctly, it's like you're just solving this at the wrong layer.
Now, you mentioned a couple times running the entire database in RAM. Is there also still an on-disk copy somewhere in case all the machines go down at once?
Of course, and this is where Sqlite comes in. It handles all that flawlessly. Sqlite is an incredibly resilient database, and so it has a variety of configurations. You can choose how much consistency and sort of how the synchronization level with disk. I would say, but at the same time, if you have 6 copies of the database, synchronizing to disk maybe doesn't really matter a whole lot, because the copy on disk only really matters when you're sort of booting up. Now, don't get me wrong; it is important to do that, but the most important thing is to ensure that nothing ever gets corrupted on disk, and Sqlite's incredibly good at that. So again, you can configure this to the level of synchronization you want, but I think the best is just to have enough RAM and then to hold everything in RAM.
And so now, you keep talking about configuration. So are there a lot of knobs? Can I really fine-tune this for my application?
You can, but I think that's one of the advantages of Bedrock is it doesn't have stupid knobs that it's like, hey, turn it this way to break it. And I think that's one of the challenges with all these databases out there is, like, their defaults were set like in 1972. And so it's like they just don't work unless you happen to be a master of the database. And, like, I don't know about you, but, like, my job is not to be a DBA. My job is to figure out how to run a business. And so I'd say to the highest degree possible, everything just defaults to something sane. Like, oh, don't choose how many threads you want. It just figures out the right number. Or it just is configured in the way that we found works best at Expensify. And if you're running a SaaS business, it's probably the best for you too.
Hey, David, I want to jump in if I can. So you talked about solving some of these problems using Bedrock and then throwing lots and lots of hardware at the problem. What about those of us that are not enterprise level? You know, I've got a server in my closet and I've got one server in a data center that does not have 700 gigabytes of RAM in it. So is Bedrock just out of the question for me? Do I need to look for something else that's easier on hardware?
I would say that person who also has the requirement of a 700 gigabyte database probably doesn't exist. It's like, I mean, the real world, like, your data scales with your with sort of your scale, I guess. And so it scales very nicely with you. If you're just starting off and you've got that server in your closet and that tiny, I guess, for some reason, super underpowered server, even though I'm not sure where you'd even buy that today. But, like, if that person existed, I would say, like, it's going to work great for you because anything will work great for you. It's like every single database in the world will meet your needs because your needs are so minimal. But I would say the challenge is to get something that is, and I would say the advantage of Bedrock is it's not going to be overkill for your needs. It's not going to force you to learn like a ton of complicated and just unnecessarily esoteric sort of sharding terminology, some weird new query language or whatever. It's like, no, man, it's just SQL. It just works exactly like you expect it would. And then it's just going to keep working like you expect it will, except as you scale up to, at the very least, Expensify sized, and we believe much, much further.
So I want to circle back around and talk a little bit about the idea of having a master that gets elected, which reminds me a lot of how SMB works. But what happens when that master goes down? So have you introduced a kind of a centralized server that is now the single point of failure?
Well, this is, I would say, it's where its most important features are. And I would say, like, the master always goes down. It goes down when you upgrade it. It goes down when your servers go down, when a whole bunch of things. It's like viewing your master as failing as some sort of an unusual event just means like you're just blinding yourself. It's like servers fail all the time. You got to plan for this. And so I would say this is where the strength of this technology comes in. So let's say you've got a cluster up and it's elected a master and everyone's like, happily humming along. And then let's just say like worst case scenario, like you lose an entire data center, which is like happens much more frequently than you think. And so like, boom, your entire data center is gone, possibly forever. And it's like, oh, shit, now what am I going to do? It's like, well, the remaining sort of nodes. And so if you run a 6-node cluster, which I think is the right number. And so there's 4 remaining. And so they'll basically connect to each other and be like, oh my God, what's going on? Who's still here? And then like, okay, there's 4 people are here. Like, okay, well, it looks like we lost those other 2, including our master. And then everyone says like, okay, well, what all commands was everyone waiting from? And it's like, okay, well, I know the commands that I escalated to the master that didn't get an answer to. It's like, okay, well, let's just elect a new master and let's re-escalate those commands to the new master, and then we'll process them and just keep on trucking. And all that happens within milliseconds. And so for us, we can lose a whole data center and it actually doesn't impact the application at all, because it obviously impacts the third of the traffic that was going to that data center, surely. But the other 2/3 just don't even notice, because the database basically just like re-escalates and reprocesses those commands and then keeps on moving. So yes, I think the automatic recovery from failure and it also automatically sort of like recovery when the servers come back online is tricky. And the other one's also important. So let's say it's like, okay, so now those other 2 servers come up. They're like, hey, dudes, what's up? And they're like, oh, man, where'd you go? You're back. That's great. And it's like, okay, well, I want to take back over. And it's like, cool. While you were gone, here's all the data that you missed out on. And it's like, okay, so it sends it over. And there's this very dicey process. It's like, okay, everyone depends upon there being a master. Everyone's going to gracefully stand down such that the new master can stand up, re-slave to the new master, and keep on moving. And so all of this happens completely automatically with no sort of user intervention. Because if your downtime, if resolving your downtime depends upon a human pressing a button, I'm like, you've just extended it tenfold. And so it's all about basically automatic failure recovery and sort of graceful handling of this sort of problems.
So we have a question from the chat room, actually. Emily the Strange says, can you pick and choose which is master? And isn't this how DNS works?
Interesting. I think DNS is a great example. DNS is a good old school technology that scales incredibly well. It's the sort of thing that no one would build today. Imagine DNS didn't exist today and someone's like, hey, I got this great idea. How are we going to do it? They're like, no, man, it's got to be like blockchain. It's got to be some crazy to like make this super complicated. But like, no, actually, it can be super simple. And DNS is probably a good model for that. As far as the master selection, so the way it works is every node has a priority. And so it brought everything sort of when you connect and search amongst your peers, everyone broadcasts their priority. And the one who announces the highest priority will be the one that everyone favors. If, for example, I try to stand up as master and you see a node that is higher priority than me, you will deny me. And it'd be like, no, David, there's someone else out there that is actually a higher priority than you. Because this happens all the time. There might be like a temporary connectivity lapse. There might be like 2 people that both think that they want to be a master, both trying to stand up. So avoiding sort of the split brain scenario where you have 2 different nodes that are simultaneously mastering is the most important thing. That is the most catastrophic failure you're going to manage. And so everything is basically about trying to ensure that everyone agrees about who the master should be, and that at any point in time there can only be one.
It's like the Highlander. There can only be one.
That's right.
So how do the nodes find each other? Do you have to go in and configure all the nodes and say, all right, this IP address and this IP address and this IP address? Or is there some sort of automated way to find them?
No, it's pretty straightforward and simple for that. I would say, like, again, I think this is another one of those problems that people like to solve, even though it never actually has. Like, the idea of just like gradually and just like instantly and unplanned adding new nodes to your database and having everything rebalance, it's like, that's a cool problem. I could see that. That just never happens. Like, in the real world, if you just do basic planning, like, you just avoid that. Or it happens maybe like once every 4 years or something like this. And so instead, we just try to keep things real simple, because simplicity just reduces the failure cases. And there's already enough failure to worry about. In this particular case, Bedrock is just it's just a command line. And so you just say -node host, and then you have a comma separated list of the various nodes. Each one is basically a DNS name or IP address, : the port it should connect to. And that's pretty much it. And so every node is configured with a list of the other nodes that it tries to connect to. Now, this also has a security advantage in that if someone just pops in and says, like, hey, give me all your data, it's like, I have no idea who you are. I'm not going to do that. And so I'd say by having everyone know the full list of configured nodes, it provides a security advantage. But also, more importantly, is it avoids any possibility of split brain. Let's say that new nodes are able to announce themselves spontaneously. It's very hard to prove that they've announced themselves correctly to the entire network. And so if different parts of the network think that different nodes are available, they might come to different conclusions as to who the master is, and that's sort of catastrophe. And so it's very simple. When you can start up the server, you just specify who all the nodes are, and then they'll quickly find each other, and then they will figure the rest out.
So one follow-up I want to ask on that is the only security that this has between the nodes, the fact that an IP address is on the list. So what happens if you do have an attacker that takes over an IP address, which, that's the thing that can happen too.
Yeah, but then you're no matter what your database is. If someone roots your database, you're screwed. If you're depending upon MySQL's janky security, it's like, that is not security. If you're counting on some root attacker not being able to access the file system, it's like, man, you got bigger problems to solve. I think that trying to solve security, like sort of kernel level security at the database layer, it's just the wrong layer. Use VPNs, use a whole bunch of other way more powerful security tools. Don't count in your database for that.
Well, the scenario that I'm thinking of is more of you've got a server in a data center, and on the next rack over, someone is able to not get into your server, but spoof your IP address. And so then I'm wondering, is that IP address the only security feature that's keeping somebody out?
Interesting. Well, then that would assume, I think, that you're basically hosting your server and just opening up a port to the world. And I would say that's not how I would suggest it. I would say instead you should probably be running a point-to-point VPN between all your key servers, and such that the VPN essentially authenticates with certificates the other servers, and then the databases connect over the VPN. But I would say you should never, with any database, just open it up to the external internet by itself. Like, that is, I don't care how good your database is, they will all get hacked.
Earlier you mentioned that all the nodes need to know all the other IP addresses. Is there any way to update this on the fly, or is that only during startup?
There's no way to update it during the fly. That requires basically reconfiguring the cluster. And that's, I would say also, I think in the real world, you just don't do that often. I think actually the perfect number is 6. No more, no less. I think that, so first, the reason I think 3 data centers is, first, 1 isn't enough. But 2 isn't that good either. Because if you should always plan that you're going to lose 1. And you obviously shouldn't keep running if you only have just the one other. Because if you only have 1 data center, you just don't know, and you can't protect against a split brain scenario. Because you could have 2 data centers that both think that they're the only one and are both hosting traffic. And then you find out later that actually you forked your entire database, and now you're really screwed. And so I think that 3 is important, such that you always have at least 2 that agree that they are sort of have quorum. So I think 3 is the magic number when it comes to the number of data centers. And then I think that actually inside each data center, you should have everything redundant. And so you should have 2 nodes inside each data center. And that means it brings you to the magic number of 6 for your databases. And so the question is, should you ever have more than 6? And I would say, no, just buy bigger servers. Rather than having a large number of small database servers, I think just buy bigger servers, because quorum is basically the median latency that it takes to talk to your nodes. And so the more nodes you have, the higher your median latency, and thus the higher the replication times, and thus the lower the replication sort of throughput. And so I think that 6 is the magic number when it comes to the number of nodes you should run. And you shouldn't just be arbitrarily adding and removing them. If you're doing that, you're just doing something wrong.
Okay, and so, I was just going to say, this is apparently hostile to auto-scaling situations, but it sounds like you wouldn't need that if you just buy big enough servers in the first place.
Yeah, I mean, I think auto-scaling is great in certain environments where you have very variable capacity, and there's a tremendous amount of savings to be had by basically not provisioning for the peak. But the problem with auto-scaling is that typically you have to go to some sort of cloud service with it. And cloud services are crazy expensive. Like, people talk about AWS being cheaper. I don't know what crack they're on. It's like the cheapest you can get for AWS is to prepay for basically like a 3-year subscription or something like this. But the amount that you prepay is the cost to buy the hardware itself. And so I think that the idea of auto-scaling to cut costs is weird when you're buying incredibly expensive hardware to support it. Just buy a ton of like hardware. Hardware is so cheap. Like, do the math for yourself and actually realize buying your own hardware is crazy cheap and super powerful. And so if just buy a ton of hardware, throw it at the problem, it's so much easier than trying to solve some sort of like crazy, but super sexy and like really fun auto-scaling problem. It's like, just buy more hardware. It makes it easier.
You know, I was walking around the conference yesterday, and they had a bunch of booths set out, and Oracle has a booth for MySQL. And I love the signage that says MySQL, the #1 open source podcast in the world. And I go, I think you're forgetting one. I think you're forgetting one. Here, I'll hold up my phone, and inside there is not MySQL. It's Sqlite.
Yeah, that's why I tell people, they're like, what, Sqlite? No one uses that. I'm like, are you kidding? It is probably 2 or 3 orders of magnitude more popular than every other database out there.
Absolutely, absolutely. So, hey, one of the things I saw as I was looking through, well, I got 3 questions I want to ask. I'm trying to put them all in serial order so you can answer them, actually. So I saw that there was a wire protocol where you could actually NC into it and type commands directly at it, and it's basically going directly to the Sqlite command line, I guess.
Yep.
Is that the same port that the peers connect on, or is that a second port?
It's a different port. So there is a sort of control port that you can connect to from localhost to basically send just like a more secure sort of control port for doing various maintenance in the server. There is a server port that they use to connect to the other nodes, and then there's I think it's called the node port or something like that, where the clients connect to. And so all 3 are different.
Okay, and there's also the MySQL port too.
Yes, and so the design of Bedrock actually is a plugin based system. And so there's this sort of core database layer on the inside, but there's a variety of plugins that you can run on top of it. And so one of which is sort of a database plugin that just has a single command, which is just query. And the query, and as you mentioned, it's very simple. Like, people love to make things complicated. It's very simple. Just netcat in, just type query, your SQL, and then it spits out the results. And you can make it more complicated than that. You can specify if you want JSON, if you want it column formatted, whatever it is. And so, but the protocol to control Bedrock is very, very simple. On the other hand, if you want to use MySQL protocol, and there are situations it's helpful. So, for example, like Mode Analytics is a great tool, and it speaks sort of the MySQL protocol. And so, if you want to connect your Bedrock database to like an analytics tool, or just if you're comfortable with SQL Pro or whatever it is, like, that's cool. It'll work with that as well. But I would say the plugin framework is really our solution to sort of the stored procedure problem. And I think that I personally think that modern applications should always be using stored procedures. I think the idea of putting SQL into your application layer is just asking for trouble. It means that you basically don't believe in security, because it means anyone who roots your web server, which is the first thing they're going to root, has sort of uncontrolled access to the entire database. Instead, I think that you should have stored procedures which actually do not just data validation, but also security checks before returning the results. So stored procedures, I think, are a really critical part of database programming. But I think the problem with most databases is their stored procedure language sucks. It's like MySQL stored procedures are super janky. And so I love C++. And so I think the best way to write a stored procedure is just to write a C++ plugin. And then it exposes sort of a command inside of Bedrock. So just as I mentioned, the database plugin has one command, which is query. If you write your own plugin, then you can just expose your own commands. And so when we use it, we actually don't use a database plugin, because a database plugin means anyone who calls me has access to my entire database, which is almost never what you want. But it's interesting for testing and sort of like fooling around. If you want to run sort of a real application, I think that you should write your own plugin, write your own sort of stored procedures, which provide sort of good validation and security checks, and then expose kind of your own API to the application layer. That is a higher level API than actually just the SQL itself.
Now, I know that Sqlite has really wonderful things like FKs and things like that are still just barely rolling out to some of the other databases.
Sure.
But it does have one thing that really distinguishes it, and that's the typeless nature of the columns. Does that ever get in the way as you're doing development?
No, it never does. I mean, I would say, all things being equal, I prefer strict typing. But yeah, I'd forgotten about that. That's never been a real world problem, I don't think.
Wow. Okay. And how about performance? Is this going to be equal to or better than running MySQL on the same machine?
Oh, absolutely. I mean, just because think about what more MySQL has to do. So with MySQL, so first you connect to a client, which is a different process. You have to serialize your request over some sort of either pipe or local socket or something like that. That has to be deserialized by some sort of inside, like a separate sort of queue. It does the exact same algorithm that MySQL would use, basically, except now when it has the results, it has to construct some sort of giant string message. Oh, actually, no, it's even worse. It's some sort of a complex binary sort of packet. Send that back essentially over the wire, and then the client has to deserialize that and give it back to you. And then, whereas with SQLite, basically, you send your command to the database. It immediately accesses the raw memory of the database, and then it sends that back to you. And so it just cuts out basically a ton of network overhead. Even if you're on the same server, there's still just a tremendous amount of overhead to every single call to MySQL. And the algorithms themselves, let's be honest, all databases are pretty much the same. Like the B-tree technology resolved in the 70s. And it all comes down to who is the most optimized. And so who do you think is more optimized, MySQL or the thing that runs on 200 times more highly sort of resource-constrained processors? SQLite is incredibly optimized. Every release, they're like, oh yeah, we reduced total CPU usage by 15% or whatever it is. Walk through the incredible micro optimizations they do, and it is so fast. And so yeah, I think that SQLite, because it just does so much less, it's able to do it so much better. And the reality is, even doing so much less is still far more than you actually need.
Hey, David, I want to jump in and go a slightly different direction.
Sure.
What license is Bedrock under?
Right now it's under GPL. I think that we've had some requests to do it under BSD or MIT licensing. I'm not super passionate about it one way or the other. I think there are pros and cons to all of that. I would say, yeah. And so I think the important thing is to get the code out there first, get people using it. If there's a strong desire to switch licenses, I'm not opposed.
So that flows into something else I wanted to know. What's the motivation behind open sourcing this? It sounds like it was working well at your company and it's pretty much done. Why did you decide to not just let it live there forever?
Well, because I think that any proprietary technology, no matter how good it is, will eventually die if it's not exposed to the open air. And I think that, so when we built Bedrock initially, and this idea of an automatic failover replicating technology across WAN connections and so forth was just unheard of. It was just insane. But now it's sort of getting traction. There are others out there that are solving similar problems in similar ways. And I think that what I like about Bedrock is it's such a real world system that's built to scale and solve actual problems. And I thought, it's like, man, this is just a great platform that other people should be using. And it just feels like we should share it with the world and see if anyone else who has the same problems can use the same solution. It doesn't cost us anything. We're already building it, so it doesn't hurt us in any way. So why not open it up? And I think we've already gotten great contributions from the community. And so I think I've obviously we use Linux. We're a huge open source advocates, and so we want to do what we can to support the community. And so one thing we do, like we're a sponsor of Sqlite, and so we think that it's just a great tool that everyone should use. And I think that Bedrock is really just the networking layer over Sqlite. And so I think anyone who likes Sqlite but wants to use it in a server environment, like, now you can. It's no skin off our back.
You mentioned you have contributors that, active real people that are pushing code in. Do you have anything like a contributor agreement? Who owns the code that contributors push in?
Good question. We haven't taken those steps yet. I mean, I guess if I were really good about it, I'd get copyright licenses and so forth. I don't think we've really we probably don't have enough contribution at this point to sort of like make it a real issue. It's been mostly just like small bug fixes and so forth. But yeah, that would be the smart thing to do.
Well, especially if you're going to change the license up, you need to make sure you have your either change it fast so that you can get everybody that's contributed on board. That'd probably be the way to do it.
Yeah, I think that makes sense. But yeah, I mean, I think open sourcing it is basically about trying to say like, hey, I think so much of the complexity of the world in every context, but databases as well. So much of the complexity is invented complexity. It's complexity that's basically that people celebrate and enjoy for some other benefit other than solving problems. And I think when it comes to database technology, people make things sound so hard, and they make it sound so esoteric, and like new technologies come out and they are the same exact thing, but they just call it different stuff to make it sound different. And that just annoys me. And so Bedrock is a platform that's designed to solve. It's like, man, pretty much all of your database needs. So like, it's not just a database, it's also a job queuing engine. And people are like, what? That's impossible. A job engine's totally different than a database. It's like, okay, well, how really? It's like, actually, you look at all the job engines out there and they're just databases. They're just basically databases that just weren't built on a real scale. They don't have like a real sort of atomic commits, or they have like really awful replication or whatever it is. It's like, why compromise? Why not have an amazing job queue? So, for example, one of the plugins for Bedrock is a jobs plugin, and it works basically just as you'd want. And that is, you create a job, you specify. When you get a job, you say which one you want or what pattern you want, and it gives it back to you. It's all atomically controlled, so every job is run no more than once. You can schedule jobs for the future. You can schedule jobs to be recurring, and you can have a hierarchy of nested jobs. And this is a very powerful jobs engine, which simply just doesn't exist out there. And I think the reason it doesn't exist is because the other jobs engines were built first to solve a very tiny problem, and then they backed into being sort of a database. Whereas this instead was saying, it's like, no, let's build a jobs engine on top of a real powerful distributed database. And then you get all the benefits of failover, replication, performance, and you also get a great jobs queue. Same thing for caching. Bedrock is also a great cache. And people are like, oh my God, that's impossible. It's got to be Memcache, because everyone uses Memcache, because Memcache is so fast. It's like, well, what really is so fast about it? Like under the hood, what algorithm do you think it's using? Oh, a B tree, just like Sqlite? Who do you think has put more effort into it? The Sqlite team, which is used by everyone in the world, or the Memcache team, which is very tiny? Oh, I guess they're both very tiny, but I would say Sqlite's way more popular than Memcache. And so if I'm going to go with a B tree implementation, I'm going to go with Sqlites. And so it's like, yeah, so now we have another plugin for Bedrock as a cache plugin. And it's a great cache because it's a distributed cache. Basically, every node has a complete copy of the cache, just that every read is hosted locally. And people are like, oh, no, Memcache is distributed cache. Well, it's not really, actually. It's just sort of a partitioned cache, which is actually very different. And in a multi-data center environment, a partitioned cache is useless. You never want to go over the WAN connection to download from the cache. You want to have everything pre-populated out. And so, yes, it's a database, it's a jobs engine, it's a cache. It's pretty much a one-stop shop for all the stuff that you really need. And it's proven at Expensify scale. And so if you're smaller than us, it's probably going to work for you too. And I think that people just get so attached to technologies the way they've been, or just complexity for its own sake. They forget, like, all this stuff is really basic, man. It's all the same stuff under the hood. We don't need to make it sort of totally different.
So we had a guest on. Sorry,
Randall's chomping at the bit there to get the mic patch back to him. Bedrock is very heavily used inside Expensify, of course. Are there other companies, other real people that are making use of it?
I don't know of any sort of notable names yet. I mean, we've had certainly a bunch of interest. There's discussion. There's both public discussion and private discussion with it. I would say I don't know that we've done a great enough job making it easy to use. The documentation is not as great as anything would like to be, but the technology is real and it's used in a real scale. I would say anyone who's really committed to actually using it, engage with us, we'll engage back. And I would say the more the community is interested in it, the more we'll invest in it. But obviously, we're a business as well, and we need to take care of our priorities. And if no one cares, well, that's fine too. I guess we're just going to keep on using it.
We had a guest on the show about a year ago that I saw at a conference who was building an adapter in Java that spoke MongoDB wire protocol and back-ended it with Postgres. And it turns out that ran on the same hardware like 5 times as fast as Mongo. That combination, because again, Postgres has been so heavily optimized, so incredibly adjusted and everything. And what's great is that the way the tables were made and built up from the documents that were coming across, they looked for commonalities and built those into common tables, so you could actually write real SQL against the back end. You can't write into it, but at least you could read from it. Really slick stuff. Go ahead.
Yeah, I'm with you in that basically people are like, oh, yeah, a document storage is totally different. It's like, no, it's not. It's just a really simple table that has full text indexing, which SQLite has had forever. And so it's like, oh, well, it's got native JSON. It's like, well, I don't know. SQLite has native JSON as well. And so it just works great. And it's like, I think people are like, oh, you had some sort of complex sort of, map reduce sort of query language or something, which no one can figure out. And so therefore, all of the new sort of document systems all have, what's that? Oh, yeah, SQL engines on top of them. And so it's like, man, it's just all SQL. SQL is amazing for what it does. And so just stop trying to reinvent it.
And it's extremely mature. And I mean, it keeps getting better, which is really cool. I mean, CTEs, things like that, are just really changing up everything. Yeah. So, yeah, it's definitely useful. Hey, we're almost out of time. One of the things that I'd like to make sure is that if there's anything that we haven't covered yet that you want to make sure our audience is aware of, I know you were kind of summarizing a moment ago, but is there anything else in that arena, in that space, that you want to make sure our audience is aware of before we have to let you go?
I mean, in general, I just think SQLite's amazing, but it gets a bad rap. I think people need to stop lusting over technology solutions to what can be easily solved in hardware and just accept the simple, awesome solution when it's just there in front of them. And so you mentioned common table expressions. I love those things. So great. And by the way, SQLite has had them forever.
Yeah. It's funny. There was a keynote at PGConf a few years ago where Richard Hipp actually says that he actually implements whatever Postgres implements. He reads the Postgres document and then implements exactly that, because the Postgres guys are really good at reading very complicated specs and coming up with human language stuff around that. So he's making sure SQLite is extremely compatible with Postgres. So it's really a good 1-2 combination. So hey, it's been great. It's been great chatting with you here. I'm excited. I want to go play with this now. Is there a Docker image for this?
No, there isn't. I think there's a public repo available at GitHub. Just go to Bedrock DB. There's some documentation there, or bedrockdb.com. And then there's a public repo. You can play with it. I don't think there's a Docker image yet, but there is an Arch and a couple other sort of precompiled binaries. But really, just pull down the repo, compile it, run it. It's super basic.
Awesome. Well, it's been wonderful chatting with you. I know there's probably some people right now reaching for the keyboard there to go download and play with this thing, like I probably will right after this show when I get a few more minutes. But it's been great having you on, David. Thank you for coming on the show and taking your time to talk to us about Bedrock.
It's been a real pleasure. Thank you.
Awesome. That was David, whose name's slid away. David Barrett talking to us about Bedrock DB. What do you think there, sir? Jonathan?
Very interesting, very opinionated guy, but he's kind of got the track record to be able to have opinions.
Right. That's always the best kind.
Yes. It's always interesting when you have an open source project that is born out of a business like this, because, they've already made it work for what they need it. And so you kind of know that it does what it says on the tin. And it's not ever going to be they're not ever going to have problems with funding, in that they're not out, holding their hat begging people to pay them for it, because they've already got their funding model down. And then, after they figured out all the funding stuff, then they said, well, we'll just open source this for the good of everybody. And that's always neat. It's always an interesting thing to see these projects and what becomes of them. Sounds like he's got some interesting.
Yeah, that's why I was surprised by the 10-year maturity. That's kind of amazing too. I mean, so this really isn't something that's only been around for 6 months like last week's was. I think was it last week or 2 weeks ago? And so it was just like fairly new in their cycle. So really, and it sounds like, you know, this is mature. This is actually working in real world production environments for Expensify, and they've now said, well, let's bring in more players. Let's see what you can help create. What plugins you can do, or you know, at least take advantage of technology that we know is proven, battle tested, and so on. So, anything else before I go through the upcoming guests?
No. Very much enjoyed getting to talk to him, though.
That was good. That was fun. It was a fun show. Yes, definitely an opinionated guy, but probably very justified in all of those opinions. So that was a wonderful thing. So coming up next week, JFrog Artifactory, which is the repo manager for binary artifacts. Following that, Krail, high performance storage networking. OffNet, which I've mentioned a few times so far, that's basically providing Wi-Fi hotspots with local content in Zimbabwe. So we'll have our first guest from Zimbabwe all the way through. Pray to the Skype gods, make everything work. I hope it's all going to work. Just added to the schedule, and it just happens to coincidentally be my birthday, so it's the day before Thanksgiving this year. This is a woman, Sarah, I forget her last name, darn it. She was one of the keynote speakers here at the allthingsopen.org conference. She was like the second or third opening keynote on the opening day, and she has this remarkable project called JewelBots. And what JewelBots are basically wristbands that are programmable. They're basically Arduinos. With a USB port and a bunch of flashing LEDs and Bluetooth connectivity and the ability to vibrate and buzz. And her project is getting preteen and teen girls programming these things so that, like, when I get near my friend, both of our bracelets glow blue. So you can tell when they're around because it's a blue light that's going on. And it's an amazing project. It's open hardware, open software, getting teenage girls to program, getting more people involved in STEM in a very needed area. Now, guys are free to use it too. There's nothing that says it's only for girls, but it appeals to girls, and that's the important thing. And so they're coding in C++. I can't believe that they're actually inflicting C++ on these poor girls. But anyway, so C++ is the language of choice. Anyway, I was so moved by the talk that I had to get her on the show. So we booked it within like 3 hours. I emailed her. She emailed me. We got the dates worked out. And so she's on the schedule coming up. It's the friendship bracelet that you can code. Immediately following that, Dell has their umbrella curly code closed curly projects. There's like 4 or 5 projects in that list. Finally, wrapping up the year pretty close. We've got a couple more slots still. But Linkerd, the transparent proxy that adds service discovery, routing, and failure handling to your containers and making things all work correctly that way. Big spreadsheets at twit.tv/floss. Go right there. That's the homepage for this show. That's the easiest way to tell somebody to subscribe to this show as well, because all those subscribe links are right there. If you have any other suggestions about people who should be on this show, please tell the project leader or community coordinator to email me, merlin@stonehenge.com. You don't have to write that down. Just remember twit.tv/floss. You probably have that bookmarked already anyway if you're already an audience member here. We have a live stream at 9:30 a.m. Pacific time on Wednesdays at live.twit.tv. We take questions from there. We have a number of questions this week, as always. So we're glad to have that in here and have people giving us feedback about what we're doing and seeing if it's working. You can follow us at Floss Weekly on Google+, and at Floss Weekly on Twitter. Excuse me. You can also follow me at Randall L. Schwartz on Google+, and at Merlin on Twitter. So as I've just said, I said I was going to talk about it at the beginning of the show. Excuse me. Just went to the allthingsopen.org conference. This is its 5th year. It's gone from like 600 people to 3,200 people. In fact, it's so big this year that they don't have any more space left. They can't run any more tracks. They're totally used up at Raleigh, North Carolina, Raleigh Convention Center. So they don't know what they're going to do. I mean, it's maybe shorter sessions or something, but it's already like an 11 track wide conference. There's already way too many conflicting things for me to be at. Some 45-minute sessions, some 90-minute sessions, some sessions that slid into lunch. So you go down and get the provided lunch and then immediately go to a room just so you'd have an extra hour with a longer thing. So half the time the rooms were actually used even during lunch period. So it was amazing, absolutely amazing. I absolutely look forward to coming back again. Todd was amazing. He was on our show, I think about 2 months ago. Speaking of that, on the first day, I was sitting in the keynote to somebody. He came up to me and said, "Hi, Randall. By the way, I'm here because you did the show on this conference." So yes, it worked. You got me here. And I went, "Oh, that's awesome. Whoever you are out there, hi, sorry, I don't remember your name, but It's like that. It's all blur for me most of the time. So anyway, and of course, from this show, I got a guest already. I've got a couple more lined up. I'm probably going to do a show on Rust. Rust looks like a really interesting language, and there was a really great community coordinator presenting there, so hopefully he'll contact me soon so we can get that going forward. From here, I'm going up to Baltimore to visit some friends, and I'm going back to Portland, back down to Santa Monica, my usual crazy schedule. Hopefully helming the big chair here for most of the shows through the end of the year. I think all of them, actually. I don't think I have any other gaps this time because I'm not going on a cruise for a while. Not until January. Then I will have to find some co-hosts for the January shows. But that's still a ways away. Anything you want to plug there, Jonathan?
No. I do not have a whole lot of traveling coming up. I'm pretty much just staying here and trying to get to work in my flyover state. In some ways, I'm one of the most boring co-hosts in that respect.
Yep. Cool. All right. And by the way, in the chat room, somebody says, is November 22 my birthday? Yes, it is. It actually is. It's also Mariel Hemingway's birthday. We're exactly the same age, and yes, we finally met, which was nice. So I got to say hi. I'm your twin brother. We used to exchange presents all the time and cards and stuff. So yeah, I'm the twin brother she never knew she had to Mariel Hemingway. Very crazy that way. Hey, well, we're running just a bit over, so I want to go ahead and wrap up. We'll see you all again next time on Floss Weekly.